Hello guys, let's answer the question to why square root of 3 is irrational. So that means in this video we're going to prove that square root of 3 is irrational. So first what we can do is express it in the ratio of p to q. And here p and q are co-primes. So what that means is that this p to q ratio, their common divisor is just 1, meaning that this is their simplest form. That means they cannot be reduced further. Now what I'm going to do is square both sides. So this becomes 3 and this becomes p square by q square. Now I'm going to move the q square up there and the 3 down there, because here we'll have on the right hand side p square by 3, meaning that here, since p and q are both integers, that means that p square divides 3 perfectly to give q square. And here 3 is a prime number, which is an important fact, because what that means is if p square perfectly divides 3, that also means p also divides 3. P square divides 3, then p also divides 3. Now this is true for any prime number. If a square divides a prime number, then the root of that square also divides that prime number. Because here, let's say you choose a non-prime number like 9, whose factors are 1, 3 and 9. Here, we know that 36 divides 9 to give 4. But we can also express 36 as 6 squared by 9. And here, we see 6 squared divides 9, but 6 does not divide 9 itself. Because in the composite numbers, one of its non-1 and non-itself factors, its proper factors except for 1, they can be expressed as a multiple of that factor. So 6 square, you can rewrite it as 3 into 2 square divide 9, and this becomes 3 square into 4 divide 9. So with composite numbers, you can see that one of the factors appears in the divisible of the square number to that prime. But for prime numbers, there is no middle factor. It's only 1 or that number. So since p divides 3, let's let p is equals to 3 into some number c. So right here we have q square is equals to 3c whole square by 3. Q square is equals to 9c square by 3. And we'll have q square is equals to 3c square. And right here we can write c square as q square by 3. And it's the same case with p square by 3. If q square divides 3, then q divides 3 as well. And we can also let q be some number 3 into d. So as you can see, p is a multiple of 3 and q is also a multiple of 3. So what that means is p and q are both divisible by 3. However, this contradicts this condition over here, which is p and q are co-primes, meaning that they cannot be reduced further. However, if p and q are both divisible by 3, that means we can simply cancel out 3 and 3, meaning we will have to, or we can reduce them, which contradicts this condition. So I'll just write it condition 1, and 1 is contradicted. So since one of the condition is contradicted, therefore square root of 3 is irrational. That is the proof why square root of 3 is irrational. And if you learned something new, please like and subscribe. Thank you.